Question 3. A student planned and carried out an experiment to determine the enthalpy of reaction with magnesium metal to displace zinc from aqueous zinc sulfate. Student used this method. A measuring cylinder was used to transfer 50 centimeters cube of 1.0 mol per DM minus cube aqueous solution of zinc sulfate into a glass beaker. A thermometer was placed into the beaker. 2.08 grams of magnesium metal powder were added to the beaker. The mixture was stirred and the maximum temperature recorded. Student recorded the starting temperature 23.9 degrees Celsius and a maximum temperature of 61.2 degrees Celsius. Show by calculation which reactant is in excess, and then use the data to calculate experimental value for the enthalpy of reaction in kilojoule per mole to power minus 1. Assume that the specific heat capacity of the solution is 4.18 joules K to power minus 1 G to power minus 1, and that the density of the solution is 1.0 grams Cm to power minus 3. Okay, so we've got two parts. It looks like one part, but it's actually got two parts. So first thing we're going to do is find the moles of what we're working with, magnesium and zinc. So the moles of magnesium, mass 2.08 over mR of magnesium, which is 24.3. Then we want to find out the moles of zinc sulfate. I'll just say zinc sulfate. How do you find out the moles of this? Well, the way I worked out the moles of magnesium, mass of mR, moles of zinc sulfate is going to be concentration times by volume, concentration times by volume. So 50, but we need to divide it by 1000 because we're going to convert it to moles per dm cubed, becoming centimeters cubed. So divided by 1000 times by 1. So that's already in moles per dm cubed. You don't need to divide it by anything or times it by anything. So we get 0.050. It's just 50 divided by 1000. 1, 2, 3. Now, therefore, actually, I need to work out the moles of magnesium first. 2.08 divided by 24.3. That will give me 0.086. Therefore, magnesium is the region in excess because it's got way more moles than 0.050. It's got more moles than 0.50. Then more moles than zinc sulfate. Then it says use the data to calculate experimental value for enthalpy of reaction kilojoule per mole to power minus 1. So first things first, we're going to need three equations. Q equals mc delta T, delta H equals Q over moles, and moles equals mass over mR. And we're trying to find the enthalpy of reaction. So Q is equals mc delta T. Q is equal to the mass. Well, what is the mass of? The mass is of water. The mass of water when we're using this Q equals mc delta T. So what is the mass of water? Well, we're not given it in the question, but we know that the density of solution is 1 grams per centimeter minus cube, and we've got 50 centimeters cubed. So therefore, the mass is going to be 50 water times by C 4.18 times by delta T temperature change. Well, temperature change is just going to be the difference between these values. 61.2 minus 23.9 equals delta T, change in temperatures. So 61.2 minus 23.9, 37.3. And that will give me Q is equal to, if we do 50 times by 4.18 mass of water times by specific heat capacity times by delta T 37.3, 7795.7. But remember, this is in joules, right? So that's just to be wary of, because the final answer needs to be in kilojoules per mole to power minus 1. Next thing we need to do is find out the moles. So moles equals mass of mR, right? Or moles equals concentration and volume. But we already found out the moles in the first part. The moles of magnesium and the moles of zinc sulfate. We know that the moles of what's it called? the moles of magnesium is in excess, therefore we're not going to use the moles of magnesium. Not using moles of magnesium. What we're going to use instead is we're going to use the moles of zinc sulfate, because that is not in excess, that is the actual number of moles, whereas magnesium is in excess. And that is the end of question 3.